we're given two matrices over here, matrix E and matrix D. And they ask us, what is ED, which is another way of saying, what is the product of matrix E and matrix D? So just so I remember what I'm doing, let me copy and paste this, and then I'm going to get out my, little scratch pad. So let me paste that over here. So we have all the information we needed. And so let's try to work this out. So matrix E times matrix D. So this is matrix E times matrix D, which is equal to, matrix E is all of this business. So it is 0, 3, 5, 5, 5, 2 times matrix D, which is all of this. So we're going to multiply it times 3, 3, 4, 4, negative 2, negative 2. Now the first thing that we have to check is whether this is even a valid operation. Now the matrix multiplication is a human defined operation that just happens, in fact all operations are, that happen to have neat properties. Now the way that us humans have defined matrix multiplication, it only works if when we're multiplying our two matrices, so this right over here has 2 rows and 3 columns, so it's a 2 by 3 matrix, and this has 3 rows and 2 columns, it's 3 by 2. This only works, we can only multiply this matrix times this matrix if the number of columns on this matrix is equal to the number of rows on this matrix. And in this situation it is, so I can actually multiply them. If these two numbers weren't equal, if the number of columns here were not equal to the number of rows here, then this would not be a valid operation, at least the way that we have defined matrix multiplication. The other thing you always have to remember is that E times D is not always the same thing as D times E. Order matters when you're multiplying matrices. It doesn't matter if you're multiplying regular numbers, but it matters for matrices. But let's actually work this out. So what we're going to get is actually going to be a 2 by 2 matrix, but I'm going to create some space here because we're going to have to do some computation. So this is going to be equal to, I'm going to make a huge 2 by 2 matrix here. So the way we get the top left entry is essentially going to be, it's going to be this row times this product. If you view them each as vectors and you have some familiar with the dot product, we're essentially going to take the dot product of that and that. And if you have no idea what that is, I'm about to show you. This entry is going to be 0 times 3. So 0 times 3 plus 3 times 3 plus 3 times 3 plus 5 times 4 plus 5 times 4. So that is the top left entry. And I already see that I'm going to run out of space here. So let me move this over. So let me move this over to the right, some space, so I have some breathing room. Now we can do the top right entry. This was the top left. Now we're going to do the top right. So the top right entry is going to